Hello, Gnatostorms, and welcome to all the new people sent by Logic. Today's topic is a silly diet. Now, there are of course a lot of silly diets out there, but the pH diet has got to be one of the dumbest. Needless to say, that hasn't stopped people from promoting it. One of these people is Ken. No, not that Ken. This is another one, who for some reason has decided to start out his video small talking about the weather.
What a beautiful city we live in here in Victoria. This is the view from my balcony. I came here a couple of months ago for Ontario, where the high was -20, and I certainly haven't looked back. Hello my friends, it's Ken Winjack from Ken Winjack Personal Training.
Yeah, not really sure what the point of that was, and I doubt you're going to find many friends around here. But hi, Ken.
Just got back from shopping and I thought it'd be a good opportunity to talk to you about pH levels in your fluids.
Okay, but since I know you're not going to do it, I would like to give my audience some background information on that topic. The fluids he's talking about is probably the extracellular ones. As the name suggests, that's the fluids outside of your cells. It's commonly divided into three so-called compartments: the interstitial fluid, the blood, and the transcellular fluid. The pH of these is tightly regulated, and is normally kept within a narrow range between 7.35 and 7.45. One of the mechanisms behind this regulation involves what's known as buffer systems. Consisting of a weak acid and its conjugate base, a buffer system prevents big changes in a solution's pH when it's within a certain range. The most important of these in the extracellular fluid is the carbonic acid, i.e. dissolved CO2, and bicarbonate system. The lungs and kidneys are also involved in the regulation. The lungs remove large amounts of CO2 through breathing, while the kidneys excrete smaller amounts of other acids and some bases. The reason for this tight control is that the function of proteins is affected by the pH. They're pretty sensitive to it and will only function probably around the pH they evolved to. In humans, this so-called pH optimum is around 7.4 for extracellular proteins, and going too far above or below it results in alkalosis and acidosis respectively, both of which are serious conditions. A pH above 7.8 or below 7 is usually lethal. I think that's enough science for now. Back to you, Ken.
Our pH levels in our fluids affect every single cell in our body, and when it's too acidic, it is the leading cause of all disease and sickness.
I'm going to have to disagree with you on that one, based on a little thing called reality. We know the common symptoms of acidosis, and unsurprisingly to most of us, they don't include all known health conditions. The actual symptoms of acidosis vary and will depend on what's causing it. They commonly include fatigue, sleepiness, headaches, and confusion. In some cases there will also be changes to breathing, and in severe ones seizures and coma can occur. Really, the whole idea of a single cause of all diseases is just stupid. It's like saying all computer problems is due to missing drivers. Every part of a system can break, and living things have a metric fuckton of parts.
Furthermore, when the pH level is acidic, it's what's stopping you from losing weight.
Which you wouldn't have to worry about anyway, since when the pH level is acidic, it's also what's stopping you from being alive.
As far as our metabolism goes, it affects it in a few different ways. First of all, our thyroid gland is slowed down, which slows down our metabolism.
Yes, hypothyroidism will cause your basal metabolic rate to decrease, but acidosis doesn't cause you to get hypothyroidism. And why worry about that anyway, when according to you, acidosis is also the leading cause of Ebola, radiation poisoning, and strokes. All disease and sickness means all disease and sickness, not just the conditions that have become buzzwords in alternative health circles.
Secondly, peptides are released in the bloodstream, and when peptides are released, it has us crave foods that are fattening.
What peptides? There's a fairly long list of peptides being released into the blood all the time. Ever heard of peptide hormones? If you haven't, well, they're a thing, and they can have a wide variety of effects. In fact, some of them have the complete opposite effects of each other. Just saying that peptides are released doesn't explain jack shit. And no, cravings are a little more complicated than that, seeing as they also involve the brain.
And thirdly, insulin and cortisol are released into the bloodstream.
Insulin is released in response to increased blood sugar, and cortisol in response to the hormone ACTH. As is the case with most hormones, a number of other factors affect their release, but as far as I can tell, pH is not one of them.
And when that happens, fat is deposited. Typically it's deposited in the midsection of the body.
Cortisol is a stress hormone, and since stressful situations used to involve a lot more running away from things trying to eat you, lacking energy wasn't exactly optimal. Because of this, under most circumstances, cortisol promotes the breakdown of both fat, carbohydrates and protein. You know, the opposite of what you said. Insulin, on the other hand, promotes the buildup of these. One of its main functions is to get the carbohydrates and fat from your food into storage. So you're right, sort of. Saying that insulin causes central obesity completely ignores how complex body fat distribution is, to the point where you're really more wrong than right.
Now the problem is this is not dead fat.
What the fuck does that even mean? Of course the fat isn't dead. Unless that means something else to you than in the rest of the English language.
That fat also releases more cortisol and more insulin.
While I very much doubt that that's what you're referring to, fat cells do release small amounts of cortisol. Exactly why they do that and whether it has a systemic effect is unclear. What is, however, very clear is that your knowledge of endocrinology only extends to the name of a few commonly known hormones. Fat cells do not produce insulin. As any middle school biology textbook will tell you, insulin is produced by pancreatic beta cells in the fucking pancreas.
So the solution to all this is, let's neutralize our body.
In chemistry, neutralize would mean that the protons and hydroxide from the acid and base has reacted completely, with neither of them being in excess. What pH you end up with depends on the strength of the acid and base used. In Kent's terminology, I'm guessing it means adding enough base to restore the pH to 7.4, or to 7 if he really drops his biscuits and thinks his blood should be neutral.
And I just got back from shopping and like to share with you some of the foods that I got, which are some of the most alkaline foods on the planet.
Oh boy, grocery themed show and tell. I can hardly wait.
We've got celery.
Ken, celery isn't alkaline. It has a pH between 5.7 and 6.
Broccoli,
which has a pH of 6.3 to 6.9, making it also not alkaline.
Kale,
6.4 to 6.8. I'm starting to sense a pattern here.
Avocados, which also have a lot of omega-3s in them.
6.3 to 6.6, and no they don't. Avocados only contain 110 milligrams of omega-3 fatty acids per 100 grams. Walnuts, by comparison, has 9 whole grams per 100 grams, and salmon has 1.8. Even McDonald's spicy buffalo sauce with its 960 milligrams contains more.
Bell pepper?
Nope, 5.2 to 5.9.
And cucumber?
And no, 5.1 to 5.8.
So what I'm going to try to do today is include a little bit of all of that in my diet, which will beautifully neutralize my pH levels.
It won't, and not just because none of that food is alkaline. The idea that your body's pH is affected by what you eat is part of the fundamental premise behind the pH diet. It's also wrong. The pH of a food item basically becomes irrelevant once it enters the stomach. From that point on, the pH is regulated by the digestive system. By the time the nutrients in your alkaline cucumber is absorbed in the small intestine, the pH will be between 6 and 7.4. But even if that didn't happen, the diet would still be a fruitless endeavor. The amount of bases in the food is nothing compared to how much CO2 the body produces, and any effect would be further reduced by the buffer systems. There's a reason why the body regulates blood pH by adjusting the buffers. It's far more efficient. In addition, the effects would only be temporary and wouldn't actually address the underlying reason for the acidosis that you don't actually have.
I hope you found that helpful today.
I didn't.
And thank you for listening.
I have a strange feeling that wasn't intended for me.
If you'd like more advice, I'd be happy to meet up with you. What I do is I do offer a free session for you to come in for an hour, get some advice, and put you through an actual workout.
Given your severe lack of knowledge on how the human body, and so probably also mine, works, I'm going to have to disrespectfully decline that offer. The pH diet is nothing but yet another easy answer providing and reality ignoring cure-all concept that alternative medicine has given us steaming piles of already. And like everything else in those piles, it's plain fucking bullshit. See you next time, Gnatterstones.
Dinsdale.